All right, this morning we are going to take a look at the standard form of a quadratic. And what this allows us to do is to find the vertex of any parabola. All right? So the standard form of any quadratic is this: f of x equals a times x minus h quantity squared plus k. All right? And in this equation, the vertex has the coordinates h, comma, k. So when we get it in this form, when we get the quadratic in this form, the h and the k tell us the vertex. And remember what the vertex is. If I have some quadratic, the vertex is this low point down here, if it's upright. All right? If it's concave up, it is the minimum. That is the vertex of the quadratic. It also tells us where the axis of symmetry is. The axis of symmetry is going to be the vertical line x equals h. So that's why we're interested in the standard form of a quadratic, because it will tell us where this vertex is. Remember, this is the vertex down here, and it will tell us the axis of symmetry, which is this vertical line right here. But there's some algebra, all right, involved with this. And let's go ahead and look at an example. All right, they're going to give you a function like 2x squared plus 8x plus 7. And after they give you the function, they're going to ask you to put it in standard form, find the vertex, the axis of symmetry, and graph it, including the x-intercepts. That's quite a bit. So what are we looking at here? What's standard form? What's the vertex? All right. What's the axis of symmetry? And let's get a graph, including our intercepts. Pretty big problem, really. But if we're going to be experts in quadratics, like I told you we would, we've got to be able to do this. So, here's how we do this. Obviously, this is not in standard form. I'm going to show you how to put it in standard form. So let's come over here where we've got plenty of room. And let's write the 2x squared plus 8x right here. And then let's leave a big gap and put the plus 7 over here, like that. All right? And the reason we're doing that is because we're going to have to complete the square. I'll show you how we do this. First off, though, anytime we complete the square, the a term has to be 1. So let's pull out a 2, and this will be x squared plus 4x. All right? Now, if you remember completing the square, we take half of the b term, which is 2, and we square it, and I said we added it to both sides. Well, we don't have both sides here. So what we're going to do, half of 4 is 2. 2 squared is 4. So we're going to add a 4, and we're going to subtract a 4, like that. Put the other set of parentheses, and then put the plus 7. What that does by putting the plus 4 and the minus 4 is it keeps us from changing the quadratic. I think everybody would agree plus 4 and minus 4 is 0. All right? So remember what we did. We took half of this b term, which was 2. We squared it. There's my 4, and then we subtracted it. Now, what I want you to notice is that to get this thing into standard form, we've got to get the square of a binomial. So I need to get this thing, this -4, out of parentheses. To get it out of parentheses, I have to do distributive property with that 2. So 2 times -4 is -8 plus my 7. And now I can put the parentheses there, and I have x squared plus 4x plus 4, and my 2 is there. And now we're getting very close to where we need to be. All right? So it's important to do that distributive property when you take that thing out of parentheses. Now, this thing right here is the square of a binomial. It always will be, if we do this correctly. So I have 2 times x plus 2 quantity squared. These two things become -1, and looky there, we are in standard form. Yay for us. We are now in standard form, which means I now know what the vertex is. The vertex is going to be -2, -1. Okay, it's -2 because this thing was a plus. If you remember from our standard form, in standard form, this thing was a minus over here. So we have to change the sign. There's my vertex, -2, -1. So we've found standard form, we found the vertex, the axis is x equals -2. All right? And then now we're able to graph this thing, okay? So my vertex is over here at -2, -1, right here. That's the vertex. -2, -1. Now, what about the intercepts? They told you to find the intercepts. I am okay on these problems if you just use the graphing calculator to find the intercepts, calculate the zeros, all right? So when you do homework tonight, just use the graphing calculator to find these two intercepts. All right, I've showed you how to do that. That'll speed things up a little bit. All right, let's look at another problem. We're going to do the same thing on this one. My function is -x squared plus 6x minus 8. Now remember, anytime we complete the square, our a term has to be +1. So the first thing we have to do here is we have to factor out a -1 and make this x squared minus 6x, all right? Remember though, how we do this, we leave ourselves a gap and we put this -8 over there, like that. Because we're completing the square inside parentheses with just this part right here, all right? So what's half of 6? Half of 6 is 3. 3 squared is 9. So we're going to add 9 and subtract 9 in here. All right. Now we need to get this -9 out of here. So I need to distribute this -1 to it, make that a +9 minus 8. And now what I have in parentheses is my x squared minus 6x plus 9. Like that. And like I said, every time, if you do this correctly, this thing right here will be the square of a binomial. All right? So that's pretty easy to see that this is x minus 3 quantity squared. My -1 is here. Then I have a +1 at the end. positive 9 minus 8. Well, there's my standard form. Yay for us. We've got standard form. Check. Once you have it in standard form, the vertex is easy. The vertex is 3, 1. The axis of symmetry is x equals 3. And I want you to notice something. The A term is negative, which means it opens down. It is concave down when you make this sketch. Because it is negative, it opens down. So when we make our graph here, 1, 2, 3, 1, my vertex is right here at 3, 1, but it's going to open down like that. And that should get us started on using the standard form of a quadratic. And it is a very useful tool for us. And we will stop there for today.